All right, so when we start talking about ratios, we look at how we can write them and compare them. If we're comparing oranges to money, then we can write that as our number of oranges over the amount of money that we spent. Now remember, if we write it as a fraction, which of our big four operations does our fraction mean to do?
Division. Divide.
Divide. So I'm really doing oranges divided by money. Now, a relationship, though, says I have to have two or more fractions, right? So let's talk for a split second. We all agree that I can have 5 oranges for $2. Do we agree with that? Right? What if I wanted 10 oranges?
That would be 10 over 4.
It would be 10 over 4. What if I wanted what if I had $6? How many oranges would I get?
You'd get 15 oranges.
I'd get 15. So I'd have $6, 15 oranges. Now, are all of those what we would consider to be proportional relationships?
Yes.
Why?
Plus 5, plus 5, plus 2, plus 2.
Okay, so if whatever I change this at, I'm changing this the same, right? I'm not going by 4 here, then 2 here, then 5 here, and 3 here. I'm going consistently, right? We call consistently, the word we use instead of consistently is we call it a constant. It's moving at the same rate each time, okay? So if I'm increasing by 5 here, I'm increasing by 2 here. If I'm increasing by 5 here, I'm increasing by 2 here.
You want us to write that?
I would, yes. So that kind of lets you know what proportional relationships look like. We're going to be operating at the same, what we call same rate, okay?
Is that for your class that you have to do?
It's for you guys. I'll tell you about it in a little bit. All right, are we ready to move on? Now, you have on your paper what says a constant speed. All right? And what that should say is if a person can actually walk the same speed okay, the same speed over a given time period. So a given time period. Then we say that person is walking at a constant speed.
Hey, Miss Embry, we need to show Miss Hoffman this. Now that
Yep.
she's
Miss
back.
Show Miss Hoffman what your mastery looks like on your homework today. Look how many 3s we got going on up there. I know, right? All right, so we're walking the same speed.
Speed.
Oh, thanks. Over a given time, and that's equal to what we call a constant speed. All right, so think about like in your car, if you're driving down the road, all right, and you sometimes have to go faster to pass a car, right? Or you sometimes have to slow down because people don't know how to drive, so you got to brake for them, all right? And so you're not going at a constant speed, right? You're either increasing, decreasing, increasing, decreasing. But then let's say you get like on the bypass, all right, and there's nobody else on the bypass. You can set your cruise control, right? And if you set your cruise control, the cruise control in the car makes the car not fluctuate in speed, right? So if I set my cruise control on 70, then I'm going to go 70 for any given amount of time. Everybody agree? It's not going to go 71. It's not going to go 69. It's going to stay 70. Everybody agree? That's considered a constant speed. All right? It's not fluctuating. It's staying the same. So we're going to talk about that today in terms of how does that relate to being able to write in proportions. All right? So let's start with our first example. All right? Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? Now, the first thing that you need to know is that proportional relationships are written as y over x. Okay? Proportional relationships are written as y over x. You put that where it says proportional relationships as, and then you put y over x in the block. I don't know what the we write, I guess. Should put the word right. These are not my favorite guided notes. Miss Holman and I are going to have to spend some time fixing them. I'm not real sure. Yeah, not greatly. All right. So we're going to write proportional relationships as y over x. All right? And we're going to start by figuring out what our y is going to be. And when we write these, this is always, the y is always going to be our distance for tonight. Okay? Y is always going to be our distance. And x is always going to be our time. So how far we're going and how fast we're getting there. So let's start by figuring out what we are comparing here. What do I know? Jaden.
Walking in minutes.
All right, so I'm talking 2 miles to what? 25 minutes. So step 1, okay, is we're going to write our given, what we call our given constant rate. All right, and I think your steps are on the top of the second page. Yeah, they are. So flip your page, and on the top of the second page, we're going to write our given constant rate. We're gonna write a fraction that represents our given constant rate. So you should be on the second page right now. We're gonna write a fraction of our given constant rate. All right, so we're going to write a fraction of our given constant rate.
What if it says speed?
Huh? Our given constant speed, given constant rate. Speed and rate are the same thing.
Which legs did it not go through it?
Not in the right order. I don't. Step 1. Write a fraction of our given constant speed.
No, wait a minute.
No. Please write that in step 1. Write a fraction representing the given constant speed.
Cross.
Yeah. Okay? So, let's do that underneath step 1. You ready? What is our given constant speed? Now remember, we're writing distance over time. So 2 miles, so that's going to equal 2 miles over what? 25 minutes. Okay? 2 miles over 25 minutes.
.0.
No, we leave it. Because remember, it's a fraction.
Oh.
Okay? It's a fraction, so we just leave it. Now it says, how many miles can Paul walk in 137.5 minutes? But it says, how many miles? So what do I not know?
How many miles?
I don't know my miles. Right?
X.
So step 2
Write a blank. Right.
is to write a fraction
Of the constant speed in terms of.
Okay, hold on.
We've already written.
To write a fraction
You're going to write a fraction
of constant speed
in terms of
in terms of the unknown. So what it is, we don't know. Okay, so we're going to write a fraction of constant speed in terms of the unknown. Well, in this case, what's our unknown? How many miles? Okay? So, if I don't know how many miles, is miles my y or my x?
Y.
It's my y. So, I would write y over, do I know my minutes or my time?
Yes.
Yeah. What do I know?
25 minutes.
No.
Oh, 137.
137.5. All right? Does that make sense? So, we write our fraction of our given constant speed, which is what we were told in the problem. So 2 miles over 25 minutes. Then we write our fraction for what it is we don't know. Now, let me ask you this question. What if they had given us the miles, but not given us the minutes? Then which of these would we not have known?
Y.
We would have known Y,
X
but we
time.
wouldn't have known
X.
X. Now, X still stays on the bottom. Okay? Y is going to always be on the top. X is going to always be on the bottom. Alright? We just fill in which ones we know and which ones we don't. Okay? You ready for step 3? You ready? Alright, I'm going to flip to a clean screen. Okay? Step 3. Well, hold on. I'm going to rephrase. Yeah. All right. Cross multiply. And then I'm going to add a little extra. You ready? Hoffman, you ready to add a little extra to that?
Cross
right
multiply.
now.
Yeah. You've got it set pulled up, don't you? No? Okay.
It's really messed up.
I know it is. Cross multiply after.
It says cross multiply.
I know, but you're going to put cross multiply and then you're going to add what I'm adding.
Oh.
After. All right, after you set fractions equal. Okay, so we're going to cross multiply after you set your fractions equal. All right, we're going to cross multiply after we set our fractions equal. So what was our first fraction? What was our first fraction? Look in step 1. What was our first
2 over
fraction?
25.
2 over 25. What was our second fraction?
Y over 137.5.
Y over 137.5. So now what can I do? Cross multiply. Alright, so let's do that. We know how to cross multiply. So I'm going to
do Miss Hoffman's butterfly.
is that where she draws the circles?
Yeah.
Okay. Alright, like that. It's not a very good butterfly. There we go. So we're going to do 2 times 137.5, and that's going to equal 25 times y. Can we all agree with that?
Mm-hmm.
Now, who's got a calculator? We
Me.
should all have one. Take care of multiplying 2 times 137.5. Garrett, what do you get?
275.
275 even?
Yep.
And that's going to equal, well, what's 25 times y?
25 block.
25y. Do we all agree with that? What would I do to solve this problem? Divide by
25 block.
25.
25.
Just 25. Garrett, you got it for me?
11.
Who?
11.
11. Now, 11 what? What did our y stand for?
Miles.
Miles. So 11 miles.
In
So-
how many minutes?
137.5.
Okay, so that's what we have to talk about. We have to talk about what does this mean? Okay? Because in step 4, we didn't fill in step 4, but step 4 says to use inverse operations. Everything comes back to being able to use inverse operations. Okay? Everybody okay with that? So that's what we're doing. Everybody good?
No.
No? All right, I'll hold tight.
I'm writing pages too.
Oh, okay, I appreciate that. Yes, baby. We're not going to worry about that. We're not going to worry about the front side. We just moved on to page 2. I didn't like the way the front side looked, so we're just skipping it. Okay? Everybody good? Yes, no, or maybe?
Yeah.
We okay? All right. So, we would say that, is his name Paul? Is that what his name
Yes.
is? Okay, we could say Paul, is he walking or driving? Walking. Walked 11 miles in what?
137.5 minutes.
In 137.5 minutes. So I want
Wait,
you to
is
think
that
about what that
okay?
really means. 2 hours is 120 minutes. So this would be 2 hours and 17 minutes. So in 2 hours and 17 minutes, he was able to walk 11 miles. Okay? That's not much, is it? So think about way back in like colonial days, when people walked to get places, and how long it would take you just to walk 11 miles. Okay, over 2 hours. 2 hours, about 2 hours and 20 minutes if we want to be close. Okay? Does that make sense? All right, let's look at our second example. You ready? I know we still have the first page, but we're moving on. Okay? So now we're at example 2. See where it says example 2? And it says a 2-variable equation. Everybody see that? That's where we are. I'm moving on from all this because I don't like it. Okay. Oh, wait. Okay, now we go. Okay. That's where I want to be. That's where I want to be.
I had it.
Yeah, you did. I messed up.
Oh, okay.
My bad. All right. So you don't have to look at any of this stuff over here. I want you to look right here, okay? Stephanie drove at a constant speed from her apartment to her friend's house, 20 miles away. It took her 45 minutes to reach her destination. On your white when working. Okay, this is not the same as the example that you have right there. On your white when working, I want you to follow those 4 steps and tell me how many miles she drove in 9 minutes.
Y over X, right?
It's absolutely always going to be y over x.
And Y represents my...
Somebody tell her. She may not have been in here today.
Distance.
Y is my
Distance.
distance, and x is my what?
Time.
Time.
Okay.
Always, Miss Hall.
I was setting it up in my head, and I wanted to make sure I was setting it up right.
Yep. Always. It's going to be always that, no matter what.